Electrical engineering is a vast and multifaceted field, but at its core, it deals with the study and application of electricity, electronics, and electromagnetism. To understand more advanced concepts, it's crucial to grasp the fundamental principles that underpin this discipline. Let's delve into some of these essential concepts. Firstly, we have electric charge. Electric charge is a fundamental property of matter that causes it to experience a force when placed in an electromagnetic field. There are two types of electric charge: positive and negative. Like charges repel each other, while opposite charges attract. The unit of electric charge is the coulomb. Secondly, we need to consider electric current. Electric current is the rate of flow of electric charge through a conductor. It is measured in amperes, often abbreviated as amps. 1 amp is defined as 1 coulomb of charge flowing per second. Electric current can be either direct current, DC, where the flow of charge is unidirectional, or alternating current, AC, where the flow of charge periodically reverses direction. Thirdly, let us talk about voltage. Voltage, also known as electric potential difference, is the electric potential energy difference per unit charge between 2 points in an electric field. It is measured in volts. Voltage is what drives the current through a circuit. A higher voltage means a greater potential difference and a stronger push on the electric charges. Fourthly, we have resistance. Resistance is the opposition to the flow of electric current in a material. It is measured in ohms. The higher the resistance, the lower the current for a given voltage. Materials with low resistance are called conductors, while materials with high resistance are called insulators. Fifthly, let's discuss Ohm's law. Ohm's law is a fundamental relationship between voltage, current, and resistance in an electrical circuit. It states that the voltage across a resistor is directly proportional to the current flowing through it, with the resistance being the constant of proportionality. Mathematically, Ohm's law is expressed as voltage equals current times resistance, or volts equals amps times ohms. This law is essential for analyzing and designing electrical circuits. Sixthly, we must consider electric power. Electric power is the rate at which electrical energy is transferred by an electric circuit. It is measured in watts. Power is calculated as the product of voltage and current. Power equals voltage times current, or watts equals volts times amps. Understanding power is crucial for determining the energy consumption of electrical devices and designing efficient electrical systems. Seventhly, we should look at series and parallel circuits. Electrical circuits can be configured in series or parallel. In a series circuit, components are connected one after the other, so the same current flows through each component. The total resistance in a series circuit is the sum of the individual resistances. In a parallel circuit, components are connected side by side, so the voltage across each component is the same. The reciprocal of the total resistance in a parallel circuit is the sum of the reciprocals of the individual resistances. Eighthly, we need to talk about capacitance. Capacitance is the ability of a component to store electric charge. A capacitor is a device designed to have a specific capacitance. It consists of two conductive plates separated by an insulator, called a dielectric. The capacitance is measured in farads. The amount of charge a capacitor can store is proportional to the voltage applied across it. Ninthly, we must consider inductance. Inductance is the property of an electrical circuit that opposes changes in current. An inductor is a device designed to have a specific inductance. It typically consists of a coil of wire. When the current through the inductor changes, it induces a voltage that opposes the change in current. Inductance is measured in henries. Tenthly, we should look at alternating current, AC, circuits. Alternating current, AC, is a type of electric current that periodically reverses direction. AC circuits are characterized by sinusoidal voltages and currents. The key parameters of an AC circuit are the frequency, measured in hertz, and the amplitude, which represents the maximum value of the voltage or current. 11thly, we have impedance. Impedance is the AC equivalent of resistance. It is the opposition to the flow of alternating current in a circuit. Impedance takes into account both resistance and reactance, where reactance is the opposition to the flow of alternating current due to capacitance and inductance. Impedance is measured in ohms. 12thly, let's talk about transformers. A transformer is a device that transfers electrical energy from one circuit to another through electromagnetic induction. It typically consists of two or more coils of wire wound around a common core. Transformers are used to step up or step down voltage levels in AC circuits. The ratio of the number of turns in the primary coil to the number of turns in the secondary coil determines the voltage transformation ratio. 13thly, we need to discuss diodes. A diode is a semiconductor device that allows current to flow in only one direction. It is commonly used for rectification, which is the conversion of AC to DC. A diode has two terminals, an anode and a cathode. When the anode is at a higher voltage than the cathode, the diode conducts. When the anode is at a lower voltage than the cathode, the diode blocks current flow. 14thly, we have transistors. A transistor is a semiconductor device that can be used as an electronic switch or amplifier. There are two main types of transistors: bipolar junction transistors (BJTs) and field effect transistors (FETs). Transistors are fundamental building blocks of modern electronic circuits. 15thly, let us discuss operational amplifiers. An operational amplifier, often called an op-amp, is a high-gain electronic amplifier with differential inputs and a single output. Op-amps are used in a wide variety of analog circuits, such as amplifiers, filters, and oscillators. They are characterized by their high gain, high input impedance, and low output impedance. 16thly, we need to talk about digital logic gates. Digital logic gates are electronic circuits that perform logical operations on one or more input signals. Common logic gates include AND, OR, NOT, NAND, NOR, and XOR gates. Logic gates are the building blocks of digital circuits, which are used in computers, microcontrollers, and other digital devices. 17thly, let's look at microcontrollers. A microcontroller is a small, integrated circuit that contains a processor core, memory, and programmable input or output peripherals. Microcontrollers are used to control a wide variety of electronic devices, from simple appliances to complex industrial equipment. They are programmed using a high-level programming language such as C or C++. 18thly, we must consider power supplies. A power supply is an electronic circuit that converts AC voltage from the mains to a stable DC voltage suitable for powering electronic devices. Power supplies typically include a transformer, rectifier, filter, and regulator. The regulator maintains a constant output voltage despite variations in the input voltage or load current. 19thly, we should talk about grounding. Grounding is the process of connecting an electrical circuit or device to the earth. Grounding is essential for safety, as it provides a low-resistance path for fault currents to flow, which can trip a circuit breaker and prevent electric shock. Grounding also helps to reduce electrical noise and interference. 20thly, we need to discuss electrical safety. Electrical safety is of paramount importance when working with electricity. It is crucial to follow safety precautions to prevent electric shock, burns, and other electrical hazards. These precautions include wearing appropriate personal protective equipment such as insulated gloves and safety glasses, using insulated tools, and working in a dry environment. Always de-energize circuits before working on them and use a multimeter to verify that the circuit is de-energized. 21stly, we have circuit analysis techniques. There are several circuit analysis techniques that are used to determine the voltages and currents in electrical circuits. These techniques include nodal analysis, mesh analysis, superposition, and Thevenin's theorem. Nodal analysis is based on Kirchhoff's current law, which states that the sum of the currents entering a node is equal to the sum of the currents leaving the node. Mesh analysis is based on Kirchhoff's voltage law, which states that the sum of the voltages around a closed loop is equal to zero. Superposition is a technique that allows you to analyze a circuit with multiple sources by considering the effect of each source individually and then adding the results. Thevenin's theorem is a technique that allows you to simplify a complex circuit into a single voltage source and a single resistor. 22ndly, we should look at signal processing. Signal processing is the manipulation of signals to extract information or to improve their quality. Signals can be analog or digital. Analog signals are continuous in time and amplitude, while digital signals are discrete in time and amplitude. Signal processing techniques include filtering, amplification, modulation, and demodulation. 23rdly, we must consider control systems. A control system is a system that controls the behavior of another system. Control systems are used in a wide variety of applications such as robotics, aerospace, and industrial automation. A control system typically includes a sensor, a controller, and an actuator. The sensor measures the output of the system, the controller compares the output to a desired value and generates a control signal, and the actuator applies the control signal to the system. 24thly, we need to discuss electromagnetism. Electromagnetism is the study of the relationship between electricity and magnetism. A moving electric charge creates a magnetic field, and a changing magnetic field creates an electric field. Electromagnetism is the basis for many electrical devices, such as motors, generators, and transformers. Maxwell's equations are a set of 4 equations that describe the behavior of electric and magnetic fields. 25thly, let's talk about communication systems. A communication system is a system that transmits information from one point to another. Communication systems can be wired or wireless. Wired communication systems use cables to transmit information, while wireless communication systems use radio waves or other electromagnetic waves to transmit information. Communication systems include transmitters, receivers, and channels. The transmitter converts the information into a signal that can be transmitted over the channel. The channel is the medium through which the signal travels, and the receiver converts the signal back into the original information. 26thly, we have digital signal processing, DSP. Digital signal processing, DSP, is the use of digital computers to process signals. DSP is used in a wide variety of applications, such as audio processing, image processing, and video processing. DSP algorithms are implemented using software or hardware. DSP hardware typically consists of a digital signal processor, DSP chip, which is a specialized microprocessor designed for DSP applications. 27thly, we should look at embedded systems. An embedded system is a computer system that is designed for a specific application and is embedded within a larger device or system. Embedded systems are used in a wide variety of applications, such as automobiles, appliances, and industrial equipment. Embedded systems typically consist of a microcontroller, memory, and input or output peripherals. They are programmed using a high-level programming language, such as C or C++. 28thly, we must consider power electronics. Power electronics is the application of solid-state electronics to the control and conversion of electrical power. Power electronic devices, such as diodes, transistors, and thyristors, are used to switch and control large amounts of electrical power. Power electronics is used in a wide variety of applications, such as motor drives, power supplies, and renewable energy systems. 29thly, we need to discuss renewable energy systems. Renewable energy systems are systems that generate electricity from renewable sources of energy, such as solar, wind, and hydro. Renewable energy systems are becoming increasingly important as the world seeks to reduce its reliance on fossil fuels. Solar photovoltaic (PV) systems convert sunlight directly into electricity using solar cells. Wind turbines convert the kinetic energy of the wind into electricity. Hydroelectric power plants convert the potential energy of water into electricity. 30thly, let's talk about high-voltage engineering. High-voltage engineering is the branch of electrical engineering that deals with the design, testing, and operation of high-voltage equipment. High-voltage equipment is used in the transmission and distribution of electrical power. High-voltage engineers must consider the effects of high voltage on insulation, conductors, and other equipment. They must also ensure that high-voltage equipment is safe to operate. Firstly, let's discuss the National Electrical Code, NEC. The National Electrical Code, NEC, is a set of standards for the safe installation of electrical wiring and equipment in the United States. The NEC is updated every 3 years by the National Fire Protection Association, NFPA. The NEC covers a wide range of topics, such as wiring methods, overcurrent protection, grounding, and equipment installation. Electrical engineers must be familiar with the NEC to ensure that their designs comply with safety standards. For example, NEC Table 310.15 details the ampacities of insulated conductors. Secondly, let's think about electrical machines. Electrical machines are devices that convert mechanical energy into electrical energy or vice versa. The electrical machines include generators, which convert mechanical energy into electrical energy, and motors, which convert electrical energy into mechanical energy. Electrical machines are used in a wide variety of applications, such as power generation, transportation, and industrial automation. The operation of electrical machines is based on the principles of electromagnetism. These are just some of the fundamental concepts in electrical engineering. A solid understanding of these principles is essential for anyone pursuing a career in this exciting and challenging field.